So, in the span of just a few days, an AI model completely disproved a 60-year-old math conjecture.
Yeah, a problem that has literally stumped some of the most brilliant human minds on Earth.
Right. And then, like almost simultaneously, a major hospital system started handing out this custom generative AI directly to patients, just sitting right there in their hospital beds.
It's been a pretty massive week.
It really has. So, okay, let's unpack this because today's stack of sources, I mean, it covers everything from high stakes geopolitical summits to, highly specific cybersecurity product
By
launches.
a lot of ground to cover.
Yeah, but the mission today, for you listening, is to cut through all of that noise. We are looking at a fundamental shift that happened this week. We're seeing what happens when artificial intelligence, well, when it stops just being a helpful tool that summarizes our emails and starts acting as an original, surprising collaborator.
Exactly. And the underlying current connecting all of our sources today is this transition from uh, basically autoregressive token prediction to actual structural reasoning.
Okay, so moving past just guessing the next word.
Right. For the past few years, we've existed in this era where AI was essentially a highly advanced autocomplete, right? It guessed the next most likely word based on its training data.
Like when your phone suggests the next text message, just on a massive scale.
Precisely. But what we are observing this week is the maturation of chain of thought reasoning paradigms.
Yeah.
The AI is evaluating multiple paths, it's recognizing dead ends, backtracking, and formulating multi-step logic.
Wow.
Yeah, so we are officially moving past the era of the AI as a search engine and entering the era of the AI as a reasoning engine. And that changes the entire dynamic of how humans interact with it, both in a theoretical lab and in the messy real world.
It really is a completely different paradigm. So let's start with the math, because the implications of this discovery are just massive.
They really are.
So OpenAI announced that one of its models successfully disproved a central conjecture in discrete combinatorial geometry. Now, before we get into the philosophical implications of a machine solving a human math problem, we need to clarify the technical side because I am definitely not a mathematician.
Fair enough.
So when the sources talk about discrete combinatorial geometry, what exactly are we dealing with here?
Let's break that down. So geometry, as most of us learned in school, deals with shapes, sizes, properties of space, right?
Right, triangles, squares, that kind of thing.
Exactly. And combinatorics is essentially the mathematics of counting and arranging things.
Okay.
So discrete combinatorial geometry is the study of how distinct, separate geometric objects, like a finite set of points or lines or polygons, can be arranged, combined, or intersected.
It sounds super abstract.
It is, but it's actually the foundational math that underpins everything from computer graphics algorithms to how our cellular networks are structured.
Oh, wow. Okay. So it has real-world impact.
Very much so. And the conjecture in question here was a deeply entrenched assumption about how these geometric arrangements behave. Human researchers had been building on this assumption or, hitting a wall trying to prove it for 6 decades.
60 years.
Yep.
See, this is where I want to push past the usual narrative, because when tech companies announce these things, it's usually framed as like a benchmark story.
Oh, absolutely. Here's a chart. We process 1 billion tokens a second.
Exactly. Or we scored 5% higher on the bar exam or whatever. But looking at the source material, this isn't a story about speed.
No, not
Right.
really.
I mean, to me, this is the difference between having a super fast calculator on your desk versus having a colleague who walks up to your whiteboard, looks at the equation you've been staring at for months, circles a variable, and says, wait, what if we look at the architecture of this completely differently?
What's fascinating here is that is the exact crucial distinction. The model didn't arrive at the answer by brute forcing 1 trillion calculations faster than a human could. It demonstrated structured, step-by-step logic to achieve an original advance in pure mathematics. To understand the mechanism here, imagine human researchers navigating a vast, incredibly complex maze.
Oh, okay, I'm with you.
For 60 years, humans have been walking into this maze, taking a specific path based on foundational assumptions and hitting the exact same conceptual dead end over and over.
Because they're all using the same map, basically.
Exactly. But what the AI did through its reasoning architecture was essentially map the maze from above. It didn't just walk faster. It identified that the foundational assumption determining the entrance to the maze was flawed.
Wait, really? So it didn't just solve it, it changed how we even look at it.
Yes. It plotted a path through a hidden side door that humans literally hadn't considered looking for.
But I mean, if an AI can map the maze from above and reason through something humans haven't been able to crack in half a century, are we entering a phase where the AI is actually the lead researcher?
That's the big question.
Because if it's finding the hidden doors, doesn't the human just become, like, the assistant verifying the machine's work? Because that feels like a total inversion of how we view our dominance over technology.
The dynamic is definitely shifting, but if you look at how the researchers themselves are contextualizing this, they don't view themselves as obsolete assistants.
No, we don't.
No, because the human still defines the value of the maze. The human asks the profound questions, they set the parameters of the exploration, and most importantly, they contextualize why the result actually matters to the physical world.
Okay, so the AI is just clearing the brush.
Right, it cleared the brush in an intellectual jungle that was simply too dense for human cognition to map manually. Think of the visual described in the sources, a graduate student in a computer lab tracing a geometric proof generated entirely by an AI.
Yeah.
She is scrolling through the logic, validating the steps, and she calls her advisor over to share a moment of genuine, profound scientific discovery.
That's incredible.
The entity that sparked the discovery was algorithmic, sure, but the mathematical truth it uncovered is universal. Math doesn't care about the origin of the thought, it just cares about the structural integrity of the proof.
That structural integrity is fascinating because it brings us to a massive pivot for today. That exact same foundational capability, the ability to reason through multi-step problems without hitting a dead end, is what allows this technology to step out of the abstract world of pure math and into the highly regulated, incredibly messy reality of a hospital room.
Yeah, if we connect this to the bigger picture, the underlying architecture is identical.
Right.
The AI is taking a massive set of unstructured variables, whether that is a set of geometric points or a patient's complex medical history, and using reasoning to map a coherent path through it.
Which brings us to Hartford Healthcare.
Yes.
According to the sources, on May 20th, they launched a platform called Patient GPT. And this is a generative AI platform built specifically for patient-facing interactions in a regulated U.S. healthcare setting. It's designed to help patients understand their medical records, discharge instructions, care schedules, all of that.
Right, the day-to-day healthcare journey.
But here's where it gets really interesting and where I have to throw, like, a massive red flag.
Okay, let's hear it.
We all know that large language models hallucinate. They are notorious for confidently making things up when they don't actually know the answer.
Very true.
So giving consumer-style generative AI directly to a patient sitting in a hospital bed, someone who is vulnerable, maybe on heavy medication and likely super stressed about a diagnosis, that seems like an astronomical leap of faith.
It does sound risky on the surface.
I mean, how is this not a recipe for an absolute disaster?
It is the most critical question regarding deployment, absolutely.
Yeah.
But the answer lies in the specific mechanism of how Patient GPT is actually built.
Oh.
The builders are not just taking an off-the-shelf open internet language model and handing it an iPad. This system relies on an architecture called Retrieval Augmented Generation, or RAG.
Okay, let's break RAG down for everyone listening, because that term gets thrown around a ton in enterprise tech, but the actual mechanics of it are rarely explained.
Yeah, let's do it. So, in a standard language model, you ask a question, and it generates an answer based on the statistical probability of words it learned during its massive pre-training on the open internet.
Right, which is why it might sound super convincing but be completely wrong.
Exactly. That is where hallucinations happen, because it might blend a fact from a medical journal with a piece of fiction from some random blog post.
Yikes, okay.
But in a RAG architecture, you structurally blindfold the AI to the open internet. You create a highly secure, restricted database, a vector database that contains only the patient's specific, verified medical chart, their doctor's notes, and the hospital's official protocols.
Oh, I see. So it's like hiring a brilliant translator, locking them in a room, and giving them only one specific verified book to translate from.
That's a great way to put it.
They physically do not have access to any outside information to draw from.
That is the exact mechanism. So when the patient asks Patient GPT, hey, what does this specific term in my oncology blood work mean? The AI does not try to guess the answer based on its training weights.
It just looks at the book.
Right. It retrieves the exact data point from the verified medical record and then And only then does it use its linguistic reasoning capabilities to translate that dense, complex medical jargon into plain, understandable English.
So the guardrails are basically built into the data retrieval layer, not just the generation layer.
Exactly.
That makes a lot more sense. I mean, it's taking the vast complexity of the U.S. medical system and acting as a reasoning interface between the hospital bureaucracy and the actual human being.
Which is huge.
Yeah, if you've ever tried to navigate a hospital discharge for yourself or a family member, you know how desperately that interface is needed. You can wait 4 hours just for a nurse to have a 2-minute window to explain a medication schedule to you.
It empowers the patient by meeting them where they are. This really represents the normalization of AI in high-stakes environments.
Right.
It is not diagnosing the patient or replacing the doctor. It is providing clarity and restoring a sense of agency to the patient during a really vulnerable moment.
So we have an AI discovering novel truths in pure mathematics, and we have an AI acting as a localized, highly constrained medical translator in a hospital bed.
Yeah, both ends of the spectrum.
But operating safely at both of those extremes requires a massive, highly secure infrastructure. And looking at the broader context of our sources this week, this digital infrastructure is being built against a backdrop of an incredibly volatile, complex, real world.
We definitely have to analyze the environment in which this tech is being deployed. The world stage is currently reflecting immense geopolitical tension. Just this week, Chinese President Xi Jinping hosted Russian President Vladimir Putin in Beijing for a highly scrutinized summit.
Right.
The sources detail their focus on deepening agreements around energy, defense cooperation, trade, and simultaneously in the U.S., there was a major legal move carrying heavy symbolic weight: the indictment of 95-year-old former Cuban President Raul Castro on murder charges related to a 1996 military attack on civilian aircraft.
Yeah, and the financial markets are acting as a real-time barometer for all this tension.
Absolutely.
The sources show market sentiment running heavily on fear, with oil dropping 4.68% to $105.42, while the S&P 500 hovered nervously around 7,432. Now, someone listening might wonder why we are bringing up oil prices and diplomatic summits in a deep dive about AI.
That's a fair question.
But this global volatility is the exact threat model that is forcing the tech industry to aggressively build out its automated defenses, right?
Precisely. Technology does not develop in a vacuum. When you have hostile nation-states, complex trade dynamics, fearful markets, the digital infrastructure housing these AI reasoning engines becomes the primary target.
Right, they're the new high-value assets.
Exactly. So we are seeing a rapid shift toward the ecosystem protecting itself. The sources highlight tools like Tenable's Hexa AI, which is an agentic cyber defense engine, and Hadrian's OpenAI auditing tool.
Yeah.
The builders realized that human analysts alone just cannot secure the perimeter against automated threats anymore, so they are deploying AI agents to secure the networks that other AI agents run on.
Right, but since we've saturated the enterprise security beat heavily this week, I kind of want to bypass a deep dive into Tenable and Hadrian and focus instead on the internal plumbing being built.
Okay, the workflow tools.
Yeah, the workflow tools. Because if we use the analogy of building a bustling, autonomous new city, the math proof and the patient GPT, those are the shiny skyscrapers everyone's staring at. But a city collapses without plumbing, traffic lights, bank vaults, and the tools shipped this week are exactly that.
They're the foundation.
Take the new Google Android CLI, for example. Google gave AI agents control of Android Studio via a command line interface. For the non-developers listening, explain why an AI using a CLI is such a massive deal.
Well, when humans use software, we use a graphical user interface, or GUI.
GUI, right?
We look at a screen, we move a mouse, we click a button that says Build App. That visual layer is designed purely for human convenience.
Because we're visual creatures.
Exactly. But for an AI, it is highly inefficient to simulate clicking a mouse. A command line interface, or CLI, strips away the graphics. It is a text-based cockpit where you type raw commands directly into the operating system.
Just pure code.
Right. So by giving AI agents access to the CLI for Android Studio, Google is removing the friction of the human visual layer.
Oh, wow.
The reasoning engine can now autonomously write the code, execute the build commands, run the tests, and iterate on failures at machine speed without ever needing to click a simulated button.
It's like the traffic lights of the new city. It dictates the automated flow of construction.
That's a good way to look at it.
And then there are tools like Vidoku, which instantly turns raw, messy screen recordings into polished, structured documentation. It's basically taking unstructured human action and structuring it for the system.
Yeah, streamlining the human-to-machine translation.
But the one that really caught my eye regarding the infrastructure of trust was a startup called Allowance.
Ah, yes. Allowance represents the bank vaults of this new autonomous city.
Exactly. Their platform lets AI agents make purchases safely by using scoped, one-time credentials. This solves a massive problem.
It really does.
Because if you have an AI agent managing your workflow, you want it to be able to autonomously pay for a new software subscription or, order office supplies. But you absolutely do not want hand an autonomous reasoning engine your actual corporate credit card number.
No, definitely not.
I mean, that's terrifying.
Right. And the mechanism Allowance uses is tokenization and scoping. When the AI determines it needs to make a purchase, it requests permission.
Okay.
The human approves it, perhaps with just a tap on their phone, and the system generates a temporary single-use credential that is locked to that specific vendor and that specific dollar amount.
Right, that's smart.
The AI executes the transaction, and the credential self-destructs. The core asset, the real financial data, is never exposed to the agent. You literally cannot scale autonomous agents acting on behalf of businesses or hospitals without that exact kind of verifiable permissioned infrastructure.
But securing the financial data and the code base is really only half the battle. Because as these systems become more capable of reasoning, there is also the fundamental question of securing the truth.
Yes.
Like, how do we know what is real when the machines can generate entirely novel concepts?
The major frontier labs are recognizing this friction. OpenAI, for instance, announced new steps this week to enhance content provenance standards.
Provenance, right.
Which is essentially the digital paper trail. They are building cryptographic watermarks and metadata standards directly into the outputs of their models, attempting to make it easier to trace and verify the origin of AI-generated content.
Which makes sense.
In a year defined by the geopolitical volatility we discussed earlier, tracing the origin of digital information is as critical as securing a physical border.
And that ties perfectly into the final piece of our stack today. Anthropic published a piece titled Widening the Conversation on Frontier AI.
Right.
It's not a product launch, it's a structural call to action regarding governance.
Anthropic is publicly acknowledging the reality of the blast radius here. A technology that is capable of generating novel geometric proofs, managing oncology patient records, and autonomously writing software cannot be governed exclusively by a small, homogeneous group of engineers and executives in Silicon Valley.
No, it can't.
The piece is an analytical argument that structural governance of reasoning engines requires diverse voices from economics, sociology, healthcare, international diplomacy.
Because the blast radius touches every single one of those fields.
Exactly.
Bringing this all together for you listening right now. Whether you are prepping for a boardroom meeting to discuss enterprise software integration, whether you are a developer compiling code, or whether you are just trying to navigate the healthcare system for a family member, the fundamental relationship you have with technology has shifted this week.
It really has.
The baseline has moved. You are no longer just commanding a static tool to retrieve information. You are collaborating with an entity capable of structured reasoning.
And exploring that shift raises an important question, something for you to mull over long after this deep dive is finished.
What's that?
We saw an AI disprove a 60-year-old math conjecture today. What happens in 5 or 10 years when these reasoning engines begin generating entirely new fields of science or new laws of physics?
Man, yeah.
How do we, as a human society, verify a monumental scientific breakthrough when we might not even possess the foundational language or the cognitive capacity to comprehend the AI's reasoning?
If the AI maps a maze that is so incredibly complex we can't even see the walls, how do we trust the map it hands us?
Exactly.
I mean, we went from expecting our technology upgrades to just give us a slightly sharper photograph on our phones to wondering how we will mathematically verify the new laws of the universe it discovers for us.
It's a massive paradigm shift.
It really is. Well, thank you for joining us on today's deep dive into the sources. Keep questioning the future, keep looking for the hidden doors in the maze, and we'll be right back here with you next time.